In grade 10 and 11, you solved trig equations using your calculator, right? If you wanted to find theta here, you would do sine inverse, and that would get your angle. In grade 11, you learned, oh, I have to do sine inverse of the positive angle to get my reference angle first, and then use my cast rule to determine that it would be in quadrants 3 and 4 because sine is negative in 3 and 4. And now that we've learned our unit circle, we're going to do a lot of them without our calculator. So this now becomes a non-calculator question. It becomes a non-calculator question because the question is, do you have root 3 over 2 on your unit circle? The answer is yes. What family has root 3 over 2 for sine? I like that. The pi over hesitation. Which one is it? Pi over 3. That's your reference angle. And then if I want to solve where is sine negative root 3 over 2, you think of your cast rule. Which quadrants is sine negative? 4 and 3. So what are your pi over 3 family members in quadrant 3? You would have 4 pi over 3. In quadrant 4, you would have 5 pi over 3. You've just solved it between 0 and 2 pi. 0 and 2 pi means once around the circle. We're done without a calculator. That fast. Yay. So whenever a question asks you for exact values, don't need brackets around there because it's just a solution. Is -1 on your pi plate for your x coordinate ever? When? At 180. But now we're dealing in radians, so the answer is pi. Done. That's it. We just solved the question. That's the only place that's -1, right? I mean, cos is negative in quadrants 2 and quadrants 3. And this is on our axes family, so I guess you could think of a reference angle, in this case, being 0. But the only answer is pi. With the axes family, I just think about my axes and write down the answer. Is tan ever 1? What family? Part of our pi over 4 family, so I already know that my reference angle is pi over 4. When is tan negative? Two and 4. So what's pi over 4 in quadrant 2? 3 pi over 4. What's pi over 4 family in quadrant 4? 7 pi over 4. This is a lot faster than using our calculator. Too fast? What? Sorry. We'll go Kino first and then. Like to figure out where, like on your, like it's pi over 4, right? Yeah, and that, it will take time, but the more practice questions we do, the better we get at it. We know that so that's why that first quadrant is so important to memorize, because that's where all your reference angles are. The rest just transfers from that. Yes, and your question?
Like it's faster to do it this way, but a radian's like actually like the most accurate measurement?
Well, accuracy-wise, a radian and a degree are both, if they're precise, they're both accurate measurements. The thing that a radian has that a degree doesn't, right? We learned that 1 radian is when the radius is exactly the same on the outside edge. So what a radian has is it has a reference. It's built into the circle. Okay? What a degree has is just someone took an arbitrary number of 360 and decided to split it up into 360. We could invent a whole new trigonometry if we decided You know what? I think it would be fun to have 827 whoa, 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 in a circle. That's our new measurement, the whoa, 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 whoa. And you could do a whole bunch of math with whoa, 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 but it would be confusing because it's an arbitrary thing, and I chose a number that's really bad for dividing into 4. But we could invent math to do that. Well, or maybe you just want to research other trigonometries. Like, what about trigonometry on spheres? If you have 3 points on a sphere, all those lines are curved. Could you do math and figure out the angles between them? How would you have to change? How would you have to change your math? Oh, that's already done for sure. Well, it's really important because if you're flying from one city to another, right? If you're flying from one city, I mean, you get elevation, but the distances between cities on the Earth, you have to do curved surfaces. So how do you do that? Because you can't just like go straight there, into the ground, pop out the other side, right? You want to make the, oh yeah, I forgot. The Earth is flat. Didn't want to ruin any science lessons coming up this year. Sorry, guys. Yeah. Secant is equal to 2. So this, whenever you have one of your reciprocal functions, you would keep the angle the same and do the reciprocal of the ratio and say if secant is equal to 2, that means cos is equal to 1/2. Is that on our pie plate? What's our reference angle for 1/2? See? And that's the other nice thing about radians is with degrees, you'd have to just go if you didn't know, right? But in radians, you can at least go, it's pi over, you've got a little bit of hesitation there, which sounds like you're getting the right answer.
It's pi over a number. What if you put a variable in for your number?
Oh.
I mean, just like it's pi over x.
It's pi over x. And
then you're always right.
no, because it can't be anything. X can only be 3.
Okay, but
But then later you just say, yeah, that's why I said x. It's actually 3.
Yeah.
pi over
But then
any
you have to
number.
write on your page somewhere.
So you would go, right, it's equal this where x is the correct number. And then you're right every single time. There's new math,
And then
right?
for any answer on like a
So every single answer, your next test, every single answer, you just go x. Or x is right. Next one, x, right? And then I mark it. No. No.
You're agreeing with me and you're putting your
Right.
like x.
Right. Okay. So x confirmed. Where I'll just define this. Where x is a check mark. That would be fine. This is.
You should do that, like put x's next to every single answer, and then like on one person's
You would freak out.
that really tiny,
Yeah.
and then you'll be like,
At the top of your page, remember x is a check mark, and that should make big, angry x's throughout your whole tests.
make an x angry.
Oh, there's an x, right? And you might have gotten sometimes the teacher give you an angry x where you've got all of this work, right? And they go, right? And that's an angry x. It's a rude, angry x. Yeah. Right? The big angry X, right? Those angry X, like you write an essay, and page 2 and 3 have angry X's through the whole thing. And now we have a little bit of extra work to do. 2 sine theta plus 1 equals 0. How are we possibly going to do this? We could move the 1 over and then divide by 2. And then, oh, it's just like the ones before. Whoa. Just isolate the sign. No problem.
That's not what I thought it was.
And our reference angle? Not pi over,
6.
pi over x. Perfect.
Oh my god, I actually wrote that.
Wait. Why was? Oh, I get it now. I can get it.
30 degrees, pi over 6. And then where is it going to be?
So
Quadrant 3 and 4. So we'll have 7 pi over 6 and 11 pi over 6. Next level.